Greetings, everyone. Welcome back. This is the continuation to the construction drawing class. This is the final chapter, AutoCAD. All right, that's the final chapter we're going to do. So, recap, everybody should have this textbook. If not, I am going to attempt to upload it. So, you should be able to find it. If not, I'm sure the class rep has one. If not, you should. I can always send one via email, etc. Okay, so the other book that we was also looking at was the Engineering Drawing for Beginners, and it's another copy that I gave you guys to look at. Similar information, although one doesn't have AutoCAD, and I think they try to explain things a little different. So it's really your choice, but just make sure you use that first one. So let's keep going. An overview, things to note. The resources for the class that you were given, engineering drawing, textbook of engineering drawing. Then we were supposed to look at AutoCAD for 2016 applications. I can't remember if I gave this to you, but if not, I should. It's a text. No, actually, this is a personal textbook we're supposed to use in class, but since we are not meeting in person, I cannot give you that book physically. So I'm going to give you a handout that I will upload and also send to Martha, but I will upload it to Muele. So the other thing to do is use the internet. Okay, so all these things can be found on the internet, and if you can't find something, the best thing to do is ask somebody, ask myself, ask one of your classmates in case you can understand something. For those of you who can meet to have some discussions, I highly recommend it because there's some things that cannot be discussed. So in case you can't understand something on your own, it's always best to ask somebody else. You can always also try and use the internet to your advantage. Okay, so the next thing is the recap of the course outline and the number of things we looked at. So you need to remember that we looked at what engineering drawings are, engineering drawings, architecture drawings, what we use them for, communication, etc. Then what are engineering drawings and what are architecture drawings? What they are, basically two-dimensional representatives of three-dimensional objects. What should they convey? In other words, what should they tell us when we produce architecture or engineering drawings? And also the different three main parts of these drawings. Okay, all this should be in the first book. There's another book that you should have, the printouts that I gave you from the beginning. All this information shouldn't be in it. So in actuality, that's engineering drawing for Ostrowski. That's the book that you should have handouts for. So another thing is we looked at sheets. We looked at title blocks, what it is, where it's located. You should have this on all of your drawings. The different types of drawings. We looked at the general rules of line work and the different types of lines. So like center lines, solid lines, thin lines, what are they for, etc. The different abbreviations that we looked at, like the symbols for diameter, center line, etc. So then we looked at dimensioning, the principles and rules of dimensioning, the different types of dimensioning, and identifying shapes through dimensions. Then other things you should note on the outlines, I believe there was some information that was in red. You don't have to look at that. We did not cover it. So we looked at scales. So in scales, we looked at enlarging scales, reducing scales, the R factor, the different types of scales. That's the plane scale, diagonal scales, and linear scales. We didn't look at diagonal and linear. We only looked at plane. Then we looked at geometrical construction. This is when we did all the drawing of circles, the drawing of lines using different techniques. Okay, so this is some of the things that we looked at. We didn't look at loci, so you don't have to look at that too. And I think we briefly looked at perspectives in pictorial projections. Just briefly, this is something you don't really have to look into, but we definitely looked at isometric projections and oblique projections. And we concluded with orthographic projections. So we finished orthography projections and I assigned a group assignment, and this needs to be turned in before the exams. So you have to find a way to turn this in. So our next section is going to be AutoCAD. Now, there are a number of things on this AutoCAD assignment, so I want to see if I can split this video into two, or I may or may not cover everything because I'm definitely going to be teaching you AutoCAD without not in person, so I'll try my best. And if you have any questions, you can ask, and I can always find a way to respond. So, AutoCAD. So, in the textbook, chapter 14 in textbook of engineering drawing, there is the theoretical aspect of AutoCAD, and it shows an outdated AutoCAD, obviously. So I'm going to send you this PDF AutoCAD 2014 tutorial, first level 2D fundamentals, so you can follow along and use. So I would recommend that you download a free trial for 30 days. Right? Or there is a free software for education for students. As long as you have a Macquarie university account, you are able to download a free version. So I'm going to try and cover what I can for you to understand mostly the theoretical aspects of AutoCAD and what it can do. But please follow along, download the trial. So one thing you'll notice that the exam in regard to AutoCAD will definitely come from the textbook of engineering drawing, chapter 14. So if you read that, you should be able to answer the questions in the exam. And I think I did tell Martha that there's definitely a question on AutoCAD. Okay? So one of the few things that we're going to look at is you need to understand not AutoCAD, because AutoCAD is a version of CAD, right? So what is CAD? This right here. CAD is computer-aided design drawing. AutoCAD is a software that produces computer-aided design drawings, basically. CAD is an electronic tool that enables us to make quick and accurate drawings with the use of a computer. So there are different types, right? But before I get into it, what you've been doing in class when we're doing all these drawings, which is what this guy is doing, was traditional drafting, which is still done, but it has its drawbacks. So when you get your rulers and squares and pencils, etc., and try and draft by hand, this is what we call the traditional drafting. Down here, what this gentleman is doing is the use of CAD, basically computer-aided design. So we are getting this traditional design and doing it on the computer. Now, obviously, computers have a high advantage over hand design. Not hand design, hand drafting. Okay? So, the first thing as to why traditional drawing has its drawbacks is information sharing. It's very difficult to share information. Well, not difficult, but it becomes a bit tedious to share information. Let me give you an example. This drawing that he's doing here, right here, if he shared it with you or somebody else and you wanted some changes, he has to go back and redraw it. Okay? He can't erase, or he can't erase it, and he has probably only made one copy. Also, in terms of information sharing, if you wanted to send this drawing to multiple people, you either have to photocopy it or redraw many of these, right? Basically, multiple copies, so that you can distribute them to different people. Now, this is how we get into the advantages of using CAD over traditional. One, drawings are neat, clean, and highly presentable. Not to say that traditional drawings cannot be neat, right? But CAD drawings are definitely more neat and more precise, right? So when you are drawing your lines, let's say we draw a line like this and like this, the chances of having clean corners are higher in CAD than in traditional drawing. In terms of cleanliness, when you draw here and you're using a pencil or pen, there are chances that as you move your pen around or this ruler or your hand on this paper, there are chances that you might smudge a little lead or ink moving around here and there. So in terms of cleanliness, yes. And because of precision, these are much more presentable. Then the other advantage is modification quite easily. Remember when I told you earlier that if this drawing here, if I asked him to change maybe a small section of this drawing, he would have to redraw this whole object. Okay, as opposed to on the computer, if I asked him to redraw a small section here, all he has to do is go back onto the computer and edit it and reprint what he has to do. Reprint the changes, sorry, the modifications. Then another advantage of CAD over the traditional drawing that we used to do before, or the traditional drawings that you've been doing and are still doing, is you can present work in a variety of formats. So while you do your drawings here, you're going to present them on paper, right? Now, which has its advantages and disadvantages, definitely. One, it means that it becomes bulky. I have to carry it around to bring it to somebody. Two, to send the drawing to someone, I'd have to probably mail them in physical mail or get somebody to get a border to bring them to you. So as opposed to CAD drawings can be sent to you via email. Um, they can be sent to you via email and also in different formats, in PDF, in PowerPoint. I can present them in various ways. It's easy to present 3Ds. You can have 3Ds that rotate, etc. So different advantages, really. Then drawing content can be continuously reused. What do they mean by that? If I draw this title block that this gentleman has right here, is difficult to reuse because every drawing that he makes, he has to reproduce it for that different page. Yet when I use CAD, I create the title block once and I can always put it in every drawing. So it also reduces time because you can do drawing content once. When you have a typical detail, let's assume that there is always this chair that you create for your house or for your school, your class, and it's the same chair that you always use. When you use CAD, you just save that chair once and you don't have to redraw it. But in this case, you would have to keep redrawing it. Then, as you can see, drawings can be shared across the network locally and globally. It's hard for you to share drawings, physical drawings, to somebody in Kenya or Tanzania or to the UK quickly or immediately as you can with CAD drawings, since you can send them via the internet. Okay, so other more advantages of using CAD over the traditional. So by using the computer, the drawing can be produced with more accuracy. That's what I was talking about earlier. Like if you have to draw some lines, when you draw lines physically, it's a little bit more difficult to get those corners. And yes, you can have straight lines, but sometimes information is not as accurate as information done on the computer. Then drawings can be more conveniently filed, retrieved, and transmitted on discs and tape. It's quicker, it's easier for you to file these drawings. They're less bulky because you can save them now on the clouds, right? And you can save them on servers, okay, and on a flash disk, on a CD, etc., whatever forms, for you to file and retrieve on a much later time, right? So you'll have to excuse me. It's a little bit more difficult to draw on the computer than if I was on a board. So perhaps with as we keep going and we keep doing this, we'll be able to find better ways to sketch on the computer. So some capabilities of CAD, right? CAD, apart from producing, everyone I think knows we produce 2D line drawings with CAD. And that's all those drawings you've been producing: plans, elevations, sections, orthographic projections, basically. We have other things that we can do CAD with, right? We can do 3D constructions or 3D drawings, such as the one he has produced right here. These are 3D drawings, okay? Then we can do renderings. Renderings is when we make photorealistic images of what we've done, which basically means almost like a picture, a pretty picture of whatever we've drawn. So whenever I draw a house and I put grass and lighting, etc., I can create some renderings to make it look realistic. Then we can do energy studies. You can do energy studies to see how efficient a building is in some of these softwares, etc. There's a number of things you can do with this CAD software. So there are different types of CAD softwares, and the one we're going to look at is AutoCAD. Okay, so and it's a popular one. It's not the one I really use, but this is one of the popular softwares that we use. Then there's also a software called SolidWorks, which is this one. Then we have ArchiCAD. I believe a number of you should know what ArchiCAD is. And then we have Revit, and Revit is the software that I use. And then we have Rhino, which is another one of software. So there are very many different types of softwares. It just depends on your price, on your pocket, and sometimes it depends on the softwares available in the region, because if they are most widely used, it means they probably have the most tutorials. But the sky's the limit with the internet. So you can learn very many different types of softwares depending on what you want to do or what appeals to you. So AutoCAD, what are we going to cover? The tutorial shall cover obviously how to open or start a project, saving a project, file extension name, the user interface. We're going to look at creating basic drawings, how to change units, create lines, circles, arcs, and commands, what's the grid and snap mode, defining positions, locating of points, the interactive method, the Cartesian and polar coordinates, the absolute and relative coordinates, direct entry coordinates. Then we'll look at, obviously, as we draw lines and circles, we're going to look at how to manipulate them. How do you erase in AutoCAD? How do you copy? How do you move? Then we're going to look at measuring and dimensioning. Then we'll look at what we call layers. Then line weights and types, and then obviously setting up the print. I'm not going to cover a lot because I usually don't, because it's just an introduction to AutoCAD for you to know what it does and what you can do. But I do definitely advise you for you to get the software and try and manipulate it. Okay, so we will continue. I'm going to do a brief overview of what I'm talking about here. So when we're starting a project, I'm going to definitely show you how to do it, but I'm going to do a small run through here. You always click this big A right here and click new, and then you'll be able to start a project. That's a brand new project. But you can also open an existing project. Same thing, you click the new button and come down to opening a project, and then draw. You open an existing drawing wherever it is. Then we're going to look at the interface. Okay, this is the AutoCAD interface. So you're going to be able to open up AutoCAD and understand and see what it looks like. This big black area here is the area in which we draw. So that's what we call the drawing area. This is where you're going to draw all your different items. Then we have, this is the application button. That's where we start the project from. Then we have the quick access toolbar where you can save, print, etc. up here. Then we have the title bar. The title bar is this section here that's telling you the title of your drawing. So this says drawing 6. Then we have the view cube. You are able to create 3D drawings or to see your project in 3D if you're drawing in 3D. So if you're not doing 3D, you might not be able to see anything. So but in here you're able to move it around. So I'll show you how it works. Then you have the navigation bar. Navigation bar basically helps you move your object around, pan, enlarge, rotate, etc. Not object, in the view. Okay, so you should be able to, if you have some 3D items, you should be able to pan, rotate, and move around. Then you have the status bar. The status bar will show you whether you're in model space or layer space, and I'll get back into that. Then you have the command line. This is where we type in all the things you want to do. Like if you wanted to copy, You can type in the word copy here and you should be able to copy. Or if you want to move something, if you want to create a line, you type in what you have to do down here and it will do what you've asked it to do. So, or it will give you the options so you can choose. Then workspace switching menu. Model space is where you model from, which is what this looks like right now. Then layout space is your pages, where how we get what drawings onto pages so we can be ready to print. Then we'll have the properties tab. Properties tab is basically if I drew a line, all the different properties of this line will be in here under this tab here, this very huge big tab here. So what do I mean by properties? I mean color, length, weight. You can see here color, line type, the scale of a line, the weight of a line, how transparent is it, how thick is it, do you have a material on it, or the layers. Okay, I'll explain layers later. Then you have the start tab. Okay, then you have the file tab. I think these things moved around a little bit. The start tab is here, this one right here. So this can, when you click it, you start a new project. Then you have the file tab right here where it says drawing 6. That shows you the different types of files. Then you have this ribbon, the one in the lime green. The ribbon has all the different things you should be able to do in Revit. So it shows you drawing lines, this right here, polylines, circles, arcs, modifying them, moving, rotating, trimming, etc., dimensioning, text, etc., layers, and so on and so forth. Okay, so this is what AutoCAD looks like. I forgot one more thing. There's the user coordinate system. When you're drawing things in AutoCAD, they're drawn either on the X and Y axis. Sometimes maybe you will also have the Z if you go into 3D. Okay, so that is AutoCAD. That is the interface for AutoCAD. So we're going to, while we're in AutoCAD again, this is something else that you'll look at. When you've opened a new file, right? When you've opened a new file, after you've clicked the big A and you're in a new file, you're able to do a number of things. You can save that file. You can save as a different name. You can bring in different files. You can export this file as something else. You can also print, or you can change units from feet to inches to millimeters, etc. That's when you're inside AutoCAD, when you're inside a file that you've already opened. So when we're looking at the CAD, at AutoCAD, we start off by drawing a point, right? We have to start somewhere. And when we're starting somewhere, we use the coordinate systems. So how do we locate points? So you're going to click in the interface. It's almost like if I gave you a grid paper. Let's assume that, or let's assume this is your grid paper, right? And I asked you to draw a square. Right? But I tell you that this point is 0, 0. This is the x-axis and this is the y-axis. So when I ask you to draw a square and locate it at maybe points 1 and 2 and 1, and it needs to be 3 squares wide and 1 square high, the point that I start from, this initial point, is what we mean when I say a method of locating points in the drawing area. So we locate points in the drawing area using coordinate systems, which means we use the x and y axis, or we also use what we call polar coordinates. So in the x and y system, so let's say in this cube here, if you are asked to locate something on the x and y axis, x and y, and we said it was 6 and 7, you'll say 1, 2, 3, 4, 5, 6. And in this case, it will be 1, 2, 3, 4, 5, 6, 7. And you can locate your point here. Okay, so then maybe we ask you to say 6, 7, and 9, which means that it will be the same place, but the 9 will be up here. Okay, so then you can create your line. So I hope you understand that this is how we locate different things, and this is how we can draw things in 3D and in 2D in AutoCAD, because we use this system of location of points. We pick points by using the X, Y, and Z axis, which is the Cartesian coordinates. But we also use the polar coordinates. I'm going to look at this. I'm going to explain this a little bit next, basically. So Cartesian coordinates, right? So Cartesian coordinates is a rectangular system of measurements that enables you to locate points with the help of the horizontal and vertical coordinates. So if I asked you to locate a line, right, at 0.24 and 0.77, so they're telling you it's rectangular because I'll do that and I'll do that, right? So you pick 2 and you pick 4. Then another point is 7 and 7. You pick 7 and you pick 7. So you can locate different points using the Cartesian coordinates, using that system. So it's almost like telling you, if I put a pin here on the board, okay, and I asked you to draw a line down here, maybe offset by certain coordinates. So I'll say it's offset by 5, positive 5 on the x-axis, and positive 7, negative 7 on the y-axis. It would mean you'd have to find where those two meet for you to give me that point. So that's one way that's Cartesian coordinates in a nutshell. Then we have polar coordinates. Polar coordinates just means we have a radius and we have an angle. Okay, so polar coordinates allow you to define a point by specifying the distance and the direction from a given point. This mode of measurement is quite helpful when you're working with angles. So what we mean is, if I ask you to find point P, you can get an point of origin, you'll find the distance, and then you find your angle to be able to give you your point. And this is when tangents come in, because you have things like sine and cosine, and then the angle is a tangent of theta. So we can locate points using the Cartesian coordinates and the polar coordinates. So we can locate them using the x and y axis, or we can locate points using a distance r and an angle given to you. Okay, so this in AutoCAD here shows you the y and x axis. So all these grids are on the y and x axis. Okay, and usually whenever you move your cursor around in AutoCAD, down here tells you the coordinates where you are. It will tell you whether you're at 0, 0 or 1, 9 or 8, 2 or 6, 4, etc. Okay, then we have what we call absolute and relative coordinates. These are just a different way of reading these coordinates here and these coordinates here. Absolute coordinate values are measured from the current coordinate system origin point, and relative coordinate values are specified in relation to the previous coordinates. What do they mean? Absolute means you will always measure from the point of origin. If this is our point of origin 0, 0, you will always measure the next point relative to this. So if I was asked to draw a triangle, a triangle, I will say, maybe they say draw a triangle at 5, 0, which means on the x-axis it will be at 5 if you go in that direction. If you're asked to draw the next point, maybe it's at 5 and 7, you'll get the 5 here and you'll get the 7 up here. So you always start from 0, 0. Then you can always finish your triangle. But what they mean by relative is previous coordinates. So as I said, if this is our origin, 0, 0. So if they tell you 5 and 7, we'll move here and this will be our point 5. Sorry, not 5 and 7, 5 and 0. Now, if they ask you to do 5 and 7 with relative coordinates, it says from previous coordinates, this is our previous coordinate, it will be 5 and 7 up. So you'll move another 5, and that will be 10 and 7 up. So it means our point will be somewhere here. And that's what we mean when we talk about absolute and relative coordinates. We are still using Cartesian coordinates and polar coordinates, but we're just measuring either from the point of origin or from the point that you've drawn last. Okay, so we're going to see that also different ways to define positions. There are 5 different ways. All these things will be in the handout that I'm going to upload. There's 5 different ways. It says absolute coordinates and relative coordinates can be used in conjunction with the Cartesian and polar coordinate systems. In AutoCAD, there are 5 methods of specifying the location of points when we create planar geometric entities. One is the interactive method. You use the cursor to select on the screen, right? So if this is your AutoCAD interface with all the lines, once you use the cursor, as you can see my cursor moving, and you just select on the screen, wherever you pick, this is what we call the interactive method. You just click, you pick a point, and maybe then you can outline that. Okay, now, sorry, excuse me. Then we have the absolute coordinates, right? Absolute coordinates, you type the x and y coordinates to locate the point on the current coordinate system relative to origin. So in AutoCAD, you'll be able to type your coordinates this way. It's always x and y first. So you will say 5 and 7. When you type 5 and 7, automatically it's going to find 5 and 7 and it will place 5 and 7. Okay? And then when you type again another x and y coordinate to locate the point in the current coordinate system relative to the origin, if your next point is, let's say 5 and 8, it will locate 5 and 8. And then your next point is probably 3 and 8. It will locate your 3 here and 8, right? This is 8, this is 7. And if your next point is 7 and 3, 3 and 7, my bad, it will locate this one here, and in most cases you've drawn a rectangle. That's absolute coordinates, where you type the x and y best off of your relative to your origin. Your origin is always 0, 0. The software will have its origin, so when you type in this information, it should be able to show you what you're doing. It should be able to show you all these different points. So I'm going to be able to show you these things after I finish going through a few of the notes. Okay, so I'll basically redo this, but well, in AutoCAD. So the next part is relative. Remember, we said relative always takes that information from the last point that you drew. So we have relative for x and y, but we also have relative for polar. Okay, so this is what you have to remember. We have relative for polar and relative for x and y. So relative for x and y would be, let me erase this so we can see how this coincide. Relative rectangular coordinates, I've explained this in the previous slide. If your first point was 5 and 7, I'll keep using 5 and 7 so that we don't get confused. When you draw the next point, it will be relative to 5 and 7. So if you say 2 and 8, it's going to move over 2 points and it's going to move over 8 points. Okay, so it will bring this point here. All right, that's what we mean by relative rectangular coordinates. Then we have relative polar coordinates. Now, when you're typing this information in, what you have to take note of is when you're doing absolute coordinates, you'll just type in 5 and 7. That means you've done all your information in the absolute method. But when you're typing in your information to get a relative point, so when you want to get a relative point, you're going to always put in the at symbol. When you do the at symbol, it will make sure that your point starts from the last point. So what we have is the relative polar coordinates, which just basically means when you're putting in your points in the software. And by the way, all these things, when I say putting them in, we are typing them in the either in the command line, or we'll just type them in the drawing area, and you'll see how that works. I'll show you how that works pretty soon. So with the relative coordinates, you will always type in the at symbol. Remember, at represents relative, and then you'll type in your distance. In this case, the distance will be 5. They won't give you 7. They will just give you whatever this distance is, the angle is. You'll get 5 on the x-axis, and the angle needed here to take you to 7. Okay, then we have the direct distance entry technique. You specify a second point by first moving the cursor to indicate the direction and entering the distance. What this means is, if this is our interface, you put your first point, right? Now, whenever you put your first point, you need to specify the direction. What do they mean? You either move your cursor to the left, here, 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 or there. Whichever direction you move your cursor to, and if you stop here and type in a distance, the line will be drawn to there. If you are in this point, you first clicked your first point. You click your first point by using the interactive method. When you move in this direction and you type in your distance, it will put that. So that's the direct entry technique. It's all about your first point, right? So you first move your cursor, and then you enter that direction, and then you put in the distance, and you'll have your point. So what I've been defining is how we draw, right? Because the whole point about AutoCAD is drawings. How do we get the lines in? How do we get those points in? Because all these lines are full of points. All these are points. If you have the x and y axis, every part of the line, or every part of a circle, or every part of an arc is a point. So when we define in positions, we're basically telling you how to get all these points to create a shape. All right. So I'm going to upload a video going over the same things in AutoCAD. All right, thank you. So that will be video 2 of this video. That will be part 2 of this video. Thank you.